Okay guys, so in this video we are going to look at two different forms of a linear equation. When we were graphing in slope-intercept form. This was useful to us because when we went to plot the graph, we would plot the y-intercept first, the b value, the initial value, and then we would use the slope to move from there. So at this point, we should be pretty comfortable with slope-intercept form since it's kind of the form we've seen most linear equations in. For standard form, however, this looks new to us. Standard form basically has the x and the y value on the same side, whereas with slope-intercept form, y was written by itself with x and the other parameters on the other side. So standard form, there's a couple different ways that we could graph. To graph it, we could either find the x and y-intercept, which I'll show you how to do on the next page, or you could simply rewrite it in slope-intercept form, which I will also show you on the next page. Of course, though, these are both linear functions. They're both linear functions because they're both degree 1. Nothing in either equation is higher than degree 1, so therefore it is a linear equation. It's just a different way of writing it. But you are able to go back and forth between the forms. Okay, so 3x plus 2y equals 6. That's in the format ax plus by equals c. So that's in standard form with the x and the y being on the same side of the equation. So what I'm going to do is I'm going to show you both options. I'm going to show you option 1 and option 2 of the way that we could graph this equation. So option 1 was to find the x and y intercepts. So to find the x-intercepts, we need to remember that the x-intercept occurs when y equals 0. So what I'm going to do is I'm going to take the equation 3x plus 2y and replace y with 0 because it's going to have an x-intercept at the value of 0 for y. And then I'm going to simply solve for x. So I get 3x equals 6 because 2 times 0 is just 0. Divide both sides by 3, giving me x equals 2. So the x-intercept is 2, 0. Now I'm going to do the same thing to find the y-intercept, except I'm going to remember that the y-intercept occurs at the value of 0 for x. So I get 3 times 0 plus 2y equals 6. And I'm kind of running out of room here, but you can see that I would solve for y and get that y equals 3 by dividing both sides by 2, giving me a y-intercept of 0, 3. So my x-intercept is 2, 0, that's right here on the x-axis, and my y-intercept is 0, 3, right here on the y-axis, allowing me 2 points, which is all I need to make a line. You only need 2 points to make a line. So that's option 1. Option 2 was to rewrite it in slope-intercept form, meaning we need to get y by itself. So if I have 3x plus 2y equals 6, I need to get y by itself. We did this back in Unit 2 when we were solving literal equations, those crazy equations with all those variables in it. So remember, we asked ourselves, what's happening to y? Well, in this case, it's being multiplied by 2 and added to 3x. So when I solve, I'm going to subtract 3x and I'm going to divide by 2. So I subtract 3x from both sides, giving me 2y equals negative 3x plus 6. The order I write it in doesn't matter because subtraction and addition is commutative. But what I do want to do is I like the x first because that's how we're kind of used to it, mx plus b. So that's why I do that. Then I divide every single thing by 2. Just like when we were doing equations with fractions, we multiplied every single thing by the denominator. When I divide, I have to divide every single thing by the number I'm dividing. So I get y equals negative 3 halves x plus 3. So if I go to graph that, that tells me I have a y-intercept of 3, and that my slope is negative 3 halves, meaning I go down 3, since it's negative, over 2 and plot my point. Ends up being the same exact line. So both options work just as well. Another thing that's important for us to do is to be able to write the equation of a line from 2 points. In order to do that, we need to use a new form called point-slope form. So from this video, you should know 3 different forms: point-slope form, standard form, and slope-intercept form. What point-slope form allows us to do is it allows us to calculate the equation of a line given the slope and a point. So the formula is y minus y sub 1 equals m times x minus x sub 1, which looks kind of confusing, but it's really not too bad. The y and the x will stay the same because every linear equation needs a y and an x value. Y sub 1 and x sub 1 are coordinates of one of the points on the line. Here we're given 2 points, so we easily have x1 and y1. M represents the slope, as we know. So when you're trying to write an equation in point-slope form, we need to first find the slope. So I'm going to do that by subtracting my y values. We did this back in Unit 3. And dividing it by my x values, 4 minus 2, giving me 4 divided by 2, which is 2. So I now know my slope, and I can use either point to plug into point-slope form. So I'm just going to use 2, 8. So I get y, which always stays the same, minus y sub 1. The y coordinate of that point is 8, so 8 is y sub 1, equals m, 2, times x minus x sub 1. The x coordinate of that point is 2. Then some people choose to simplify it into slope-intercept form. And so to do that, I would distribute the 2 first, giving me 2x minus 4. And then I'd add 8 to both sides to get y by itself, because again, that's what slope-intercept form looks like, leaving me with my equation y equals 2x plus 4. Let's try one last problem, putting it into slope-intercept form, or point-slope form. So I start by finding slope. Change in y, subtract my y values, divided by change in x, subtract my x values, gives me 20 divided by 5, which is 4. Point-slope form again is y minus y sub 1 equals m times x minus x sub 1, allowing me to plug in values that I know. My m value is 4, and I'm going to go ahead and use this point. It doesn't matter which point you use, you're going to get the same equation no matter what. So I get y minus, the y coordinate 7 equals 4 times x minus x sub 1, giving me y minus 7 equals 4 times x plus 3, which I'll then distribute the 4 to give me y minus 7 equals 4x plus 12. Finally, adding 7 to both sides to give me y equals 4x plus 19. This is slope-intercept form. This is point-slope form.